Today we're going to look at one of the core principles of AI, vector databases. Hi, I'm Christian.
Hi, I'm Ivo.
And today we're going to look at vector databases. It's a very important concept of artificial intelligence.
Cool.
Yeah. Let's take it away, I guess.
Yeah.
Well, vector databases, maybe a little bit about, you heard of it probably, but maybe let's take a look at why you want to use vector databases. A vector database is something that makes you able to search on the meaning of text or video or images and those kind of things. It's more about the context and the semantics of a text, for example. So let's take a look at, for example, the word food. If I want to search on that on a regular database, you might find something similar, and then it will find something like food, because the characters of that word kind of resemble it, right?
Yeah, and if you pronounce it not too clearly, then they sound very alike as well.
Yeah, but actually they don't mean the same. They don't have any connection.
No.
Well, at least they shouldn't have any connection. So we're more into the semantics of a word. Well, what is the meaning?
Yeah, the difference would be that in traditional, in a SQL query, you would do some full text search, and then you would find both occurrences because they were very similar.
Yeah, indeed. Yeah. But how do we work with semantics? We're going to look at characteristics of a text or something. So to have an example, we're going to look at how you can not rate a word, but a person. And psychology, there's something like the Big 5 personality traits, and on these traits you can score a person to know how he would behave and what the characteristics of that person are. We can take one of them, for example, the extraversion, so how extrovert or introvert is a specific person. So we take Lucas and we score him on a score from -1 to +1. And for example, you can say Lucas is a little bit introvert, so he's a minus 0.4 extrovert.
Yeah.
And we can draw that on a line. And when we take a second trait and rate him on that trait, for example, 0.8, we can draw an arrow, right? So we get
because you have two coordinates.
We get such a vector, right?
Yeah.
And the thing is that you can do that with multiple dimensions, of course, but we people can visualize 2 and maybe 3 because then you're in the cube.
In the end, it doesn't fit in my mind anymore.
Yeah. So with 5 traits, it already becomes quite difficult to visualize.
How would you even draw that?
So for this purpose, we will stick in the 2D space.
Yeah.
But you can imagine that if you have other persons and also rate them on those extrovert and the other traits, you get different arrows. So you can see that, for example, John and Lucas are more equal in how they behave than Scott and Lucas would.
Yeah, you have a lot of personality tests where you draw a graph or a pie chart or whatever based on all the questions that you've answered, and it brings you a profile. Yeah. So this would be something like that, right?
Profiling a person. And this and with vector databases, you profile not a person, but you profile text, entities. For example. Entities, documents, whatever. Okay. So that's a little bit how a vector would work. You take dimensions and then you rate on that dimension. And then in a vector database, that would not be 2, 5 or something dimensions, but it will be hundreds or thousands of dimensions. What those dimensions are, probably not something like extraversion or something. Is the way the model is trained. It's not a human readable thing or something. It's just they train a model and then they come up with dimensions that make it the model able to make differences between the meaning of a text. Yeah. All right. So if we then take, for example, the vectors of food and all those vectors combined, we call that an embedding. So we take the embedding of food, and I just now showed the first 25 floating point numbers, but there are more than 1,000, and we would compare that to hamburger and food. Then hamburger would have way more similarity in all those vectors than food would have.
Because the hamburger is food, so they have a lot of traits in common.
Yeah, indeed. Yeah. Although the words don't look alike.
No, not at all.
Now, for example, we have here the word king in a 50-dimension model. So you see it's rated on 50 dimensions. And in this case, I rated it from -2 to +2 to make some more nice coloring. And you can compare that, for example, to the word man and woman. And then you see, for example, that man and woman are quite related. You see some different colors, but most of them are quite similar. Yeah. And king might be a little bit more towards men than towards women, for example. But yeah, you see already that man and woman are quite related because we were talking about gender and those kind of things. Yeah. But the fun thing is you can calculate with these numbers. For example, if I take the numbers for king, the vectors for king, and I subtract man, but then plus the woman, you get something like this. And
so you take the man out of the king and you add the woman?
Yeah. So what would that be?
A queen.
A queen, yeah. And if you look at the embeddings for queen, that actually is quite similar to king minus man plus woman. Yeah. And so if you would ask a model, hey, I'm looking for a female king, then you probably would end up with a queen. Although the words don't look don't look the same. Okay, so that's a way of how a model can determine semantics about text, for example.
And those 50 things that you use to calculate, how do you get there? That is probably the real basis of how to calculate those semantics. That's the foundation of the model, I guess.
Yeah, so you can choose a particular model, and in Azure they have multiple models available. You can host your own. And then you give it a text, for example, and it will give you the embeddings back in a couple of thousands of dimensions. Yeah. And indeed, how the model does that at the back, that's
to really set up those dimensions. Yeah, that is where
the model comes
where the real work is.
Yeah, indeed. So now we need to determine what vectors are close to each other. Yeah. There are multiple ways of doing that. Oh yeah, this one. For example, I have here 4 vectors, and again in the 2D space, because that's what we kind of imagine.
Yeah, easy to understand.
So which of these points are most related? Maybe it's A and D or A and B. Well, you could look, for example, at distance. So the distance between A and D is smaller than A and C or A and B. So you might think maybe A and D are related to each other. But if you look at the vectors, they're actually the opposite.
Yeah, they're in opposite directions. So one would be the man and the other would be the woman, for instance.
Depending on what you want to accomplish, this would still be a valid option. We call this the Euclidean distance. But in most scenarios, we're not looking in things that are opposite, for example. So we're mostly looking in directions. And you could, for example, look at the angle between two vectors. So the vector angle between A and B is smaller than the other ones. Yeah. We call this the cosine similarity. And this works almost every time pretty well, but depends on what you want to accomplish. And the dots of the Euclidean distance might also work.
Yeah, because I can imagine that there are there are many similarities between A and D. Well, they're opposite directions, but if you look at A and B, the cosine similarity is very big, but B is much bigger, much longer.
So, for example, with text, it works well because maybe it's more strong or emphasized or something, but the meaning is the same. But if you look at other things, things that are closer together are more related, for example. So it kind of depends. There's also a dot product that actually looks at angles and the length of the vectors. And most of the times the cosine similarity works best. But you can you can do some juggling with it and see what works best for you. So we do the cosine similarity again with those two traits of the person, so Lucas and John. You see there's a way higher cosine similarity than between Lucas and Scott. So if we see what's similar, then those two persons would be similar.
Yeah.
Okay, and that's also what we're going to do in a vector database. So in my database I have records like documents or products or records with content.
Yeah.
Of those records I calculate the embeddings. So I send data I want of that record to a model, get an embedding back and store that in the database. So every time I update or insert a record, I have to update also that
So your embedding is kind of your unique signature for that record.
Yeah.
How you can recognize it very fast and compare it to other records.
Yeah, so the meaning of that record.
Yeah.
And then if I want to query on something, for example, hey, when will my order be delivered?
Yeah.
I want to have information about that. I can also create an embedding of that question. And then with the cosine similarity, I can compare the embedding of my question to the documents in my database. And that will search, and then I get results like a normal database would, and I can do a top 3 or a top 5 or whatever, and order by the similarity, and then I could get the proper results.
Yeah.
So let's try to see that in
How
practice.
does that work in practice?
I have this database here on Azure, only 2 tables. Document table and a product table, and just take a look at the products, for example. I have 17,225 products, and actually there are musical instruments and those kind of things.
With very nice and extensive descriptions.
Yeah, so I have title and description, features, maybe images, even unstructured data like a JSON with all kinds of information about the product.
This would be a catalog for a web shop.
Yeah, indeed. And I have the embedding. So what I took was the whole record, send it to a model, hey, create me an embedding of this record, and it sent me an embedding back, and then it's just 1,500 something floating point numbers that give meaning to this record.
Yeah.
To me it doesn't say anything, but yeah, to the model it is. So now I want to be able to query on it, and I have in the document database I have like a dozen documents related to my store, like return policies and those kind of things.
Yeah.
Okay, so now I want to ask him a question. For example, and I go to Postman here. I need to have an embedding for my question also. So I sent that to Azure OpenAI, to my text embedding small model. So that's a specific model I used to create the embeddings.
Yes.
And then I can ask him, when can I receive the instrumented / played with? Well, I don't talk about guitars here. I don't talk about delivery, but I hope my database will understand what I'm talking about.
Yeah, Slash is the lead guitar player for Guns N' Roses.
Yeah, maybe that shows our age, but
it does.
Yeah. Famous guitar player. Yeah. Okay, let's ask for the embedding. Here it is. So, quite a lot of numbers, so I have to select all these 1,500 something numbers. I copy it, go back to my database, and I'm going to use this query. So I have to declare my variable. It's of type vector. That's new in SQL 2025, and also on the Azure databases like the Azure SQL database and the managed instance. You have
an actual data type.
An actual data type.
Yeah, cool.
Actually, you can do it also in the older SQL versions. So just create a table and then have it store numbers. There's also a vector. You can still do it, but then the
vector is made up of a lot of numbers.
Yeah. So then the query would be a little bit needs a little bit more work, but now it's included.
You used to be able to store JSON and XML also as text in SQL, of course, but now they have their own data types.
Yeah, indeed. Yeah. So I pasted it in, and then I can say, well, from my products, I want everything, and also something called a score, and I can calculate that with the vector distance. Also a new function, and here I can specify the way I want to calculate the distance. So we have seen the dot product and the Euclidean distance and the cosine similarity. That's what we're going to use based on the embedding stored in the database, and then the distance to the embedding variable I just pasted in. And I can also do that same thing with the document, because I want to query both products and documents in my database. So let's execute it. And it found, it's at the top 4, so 4 products. And I found a /signature wah-wah guitar effect pedal. Yeah, probably used it. I didn't say guitar, so instrument. Yeah, it's part of the instrument. Yeah. And some electric guitars and a Paul Stanley electric guitar. Sounds reasonable as something that Slash would play with. Yeah. And the documents it found was, for example, the electric guitar starting guide and a delivery policy. I never used the word delivery. I said, when can I receive it? Yes. But still, it found this document. And it was actually quite fast, right? It was like a second or something. Yeah. And 17,000 products in the context of those things, the meaning of those documents. And this is not a premium tier SQL Azure database? It's actually the smallest I could get. So it's basic 5 DTU for €5 something, €4.50 a month. Yeah, the cheapest one. Cheapest one you can get, and it's still blazing fast in finding all this, this information. That's impressive. So it's really cool, and it's also just baked into SQL Server, so you don't need any fancy vector database product or something. You can do the same with those products, and for example, Cosmos DB is also very good ways of working with vectors, for example. But if your data is already in SQL, why not store it in SQL? Yeah, cool. Yeah, that's what I want to show you. And how would you? I can imagine that if someone visits the web shop and they could just enter a random question and they get some products and some information on delivery. Yeah, that's really giving you more context in the web shop. So that's a very powerful scenario. Yeah, and then we're talking about RAG, Retrieval Augmented Generation. You would send these documents to the large language model to make a real answer out of it. So otherwise it will just, here's your delivery policy. That's not what I asked for. Yeah. But based on the question, hey, when can I receive it? And the document delivery policy, then the large language model would be able to say, well, it's depends on what's in here, probably something like 7 days or something. Yeah. You will be able to receive your electric guitar. Yeah, so this would really be helpful in a chatbot situation where you ask a question to a chatbot and you get some human-like response with some links to the products directly. And indeed, very cool. Yeah, nice. Okay. Then that's it. Okay. Thank you for watching, and see you next time. See you next time. Bye.